Today's topic is analytic function. Before we get into solving problems, we have to get to know what the definition is. Consider a function f of z. So this function is said to be analytic at a point z0 if it is differentiable at z0 and in its neighborhood of z0. So for solving problem, it's necessary to remember something called CR equation or Cauchy-Riemann equation. There are two forms, Cartesian form and polar form. So Cartesian form, this is the function f of z is equal to u plus iv. So you have to differentiate this with respect to x and y for Cartesian form and with respect to r and theta for polar form. So you're going to partially differentiate. Dou u by dou x is equal to dou v by dou y and dou u by dou y is equal to negative of dou v by dou x. Partial differentiation. And here also applies the same. In polar form, you have to partially differentiate u with respect to r, which is equal to 1 by r into dou v by dou theta, and dou u by dou theta is equal to negative of r into dou v by dou r. Now we get into the problems. So here comes the first problem of Cartesian form. So by the question you get to know what is u and what is v. So this will be a u and this is v. You're going to differentiate u with respect to x. You'll be using quotient rule. So denominator into derivative of numerator, that will be 2x minus the numerator into derivative of denominator will be 2x divided by denominator the whole square. When you simplify this, you get the answer as 4xy square by x square plus y square the whole square. Next, you have to differentiate u with respect to y. Same thing, use the quotient rule. You get the answer minus 4x square y and x divided by x square plus y square the whole square. So you shouldn't stop here and you have to partially differentiate v with respect to x and y if necessary. So differentiating, so v is nothing but 2xy by x square plus y square. So we partially differentiate v with respect to y. That will be the denominator into derivative of numerator, that is 2x minus 2xy by differential of the denominator, that is 2y divided by denominator whole square, which gives the answer to 2x cube minus 2xy square by x square plus y square the whole square. So according to Cauchy-Riemann equation, you have to see whether if dou u by dou x is equal to dou v by dou y. By the answer, we get to know it is not equal. So the final answer, we can say that CR equations are not satisfied and the given function is not analytic. So first question we saw that it does not satisfy CR equations and it is not an analytic function. Next we can move on to the second question. So this is your second question where u is 1 by 2 log x square plus y square and v is tan inverse of y by x. So you're going to partially differentiate with respect to x and y. So differentiating u with respect to x, 1 by 2 remains the constant. Log of x square plus y square is 1 by x square plus y square. Since we are differentiating with respect to x, y square remains 0 and x square is 2x, which is nothing but x by x square plus y square. And differentiating u with respect to y, 1 by 2 remains constant. Log of this will be 1 by x square plus y square. Since we are differentiating with respect to y, x square becomes 0 and y square is 2y. So the answer is y by x square plus y square. Now we have to differentiate v with respect to x and y, where v is tan inverse y by x. What is tan inverse of y by x? That is 1 by 1 plus x square. So differentiating v with respect to x, we get 1 by 1 plus y by x the whole square into x of 0. X of, again you have to use the quotient rule since you are differentiating x which is in the denominator. So x into differential of y, that is 0, minus y into differential of x is 1 by the denominator square. So that gives the answer. This term will become 0. You get minus y by x square. So when you simplify the whole answer, you get minus y by x square plus y square. Next, we have to differentiate v, that is tan inverse y by x with respect to y. That will be 1 by 1 plus y by x square into 1 by x because we are differentiating with respect to y is in the numerator, so it becomes 1. So that will be 1 by x, which the answer simplifies to x by x square plus y square. So by this we get to know that since the CR equation is satisfied, it is a analytic function. Next we'll move on to the polar form. So here comes the first problem of polar form, that is log r plus I theta. So u is log r and v is theta. you're going to differentiate u with respect to r. Log r is nothing but 1 by r, and differentiate u with respect to theta. Since we don't have theta term here, that will be 0. Next, v is theta, so differentiate v with respect to r. That will be 0 because we don't have a r term here. And differentiate v with respect to theta. Since we have theta, differential of theta is 1. So this is the polar form of the CR equation. Dou u by dou r is equal to 1 by r into dou v by dou theta. So here dou u by dou r is nothing but 1 by r. And according to the equation, it is 1 by r of dou v by dou theta. Dou v by dou theta here is 1. So you can see that 1 by r is equals to 1 by r. Dou u by dou theta is 0 and dou v by dou r is 0. Therefore, the CR equation is satisfied. So here comes the second question of polar form. This will be your u and this will be your v. Differentiate u with respect to r. This terms remain constant because we don't have r term here. Differentiate this. That will be 1 minus 1 by r square into cos theta. Differentiate this r will become 1 and 1 by r is nothing but minus 1 by r square. So differentiate u with respect to theta. This term remain constant. You are going to differentiate cos theta. So r plus 1 by r remains constant. Cos theta is minus sin theta. And you have to differentiate v with respect to r and theta. Now v is r minus 1 by r. Differentiating with respect to r, that becomes 1 plus 1 by r square. As I told you, it's just a normal differentiation. 1 by r is nothing but minus of 1 by r square. So minus and minus becomes plus here. Sin theta remains constant. Sin theta. So differentiate v with respect to theta. This term remain constant. So r minus 1 by r remains constant and sin theta is nothing but cos theta. So we have your Cauchy-Riemann equation polar form. Dou u by dou r. What do we have here? That is 1 minus 1 by r square of cos theta is equal to 1 by r of dou v by dou theta is nothing but r minus 1 by r of cos theta. So when this r is multiplied inside, r and r get cancelled. Minus 1 by r into 1 by r is 1 by r square. That will be 1 minus 1 by r square cos theta. So we get to see that dou u by dou r is equal to 1 by r of dou v by dou theta. So next is dou u by dou theta. Dou u by dou theta, we have r plus 1 by r of minus sin theta. Minus sin theta, we can take it outside. So which is equal to, so we have r into dou v by dou r. Dou v by dou r is 1 plus 1 by r square into sin theta. Sin theta, when r is multiplied inside, you get r plus r square and r get cancelled. So that will be 1 by r into sin theta. So if this minus shifts here, that will be r plus 1 by r of sin theta is equal to r plus 1 by r of sin theta, this negative sign. So you can see that dou u by dou theta is equal to negative of dou v by dou r. So therefore CR equation is satisfied and it is analytical function.